Let's get some practice computing a polytropic index for a process. We can consider a piston that's expanding so that the gas in the cylinder has lower density, and if this is done in such a manner that it is a polytropic process, then if we know the pressure and volume at the beginning and the pressure and volume at the end, we ought to be able to figure out the polytropic index as long as we know that it is a polytropic process. That last detail is important. If you don't know anything about the process, you could connect those two endpoints with a straight line or an infinite variety of curves. What we want is to figure out the index for a particular type of curve. Okay, so the curve that we're interested in is described by this formula, pv to the n equals constant. So that means that it must be true at both endpoints and any points in between. So we can write that p1 v1 to the n must equal p2 v2 to the n. Well, if we solve for the ratio of p1 over p2, we can take logs of both sides, and the funny thing is it doesn't matter whether these are log base 10 or natural logs, that'll all come out in the wash. But we're trying to solve for n, so the reason to do this is that we can use the property of any logarithm, which is that you can bring that exponent out front of the log on the right-hand side of the equation. Now we have something that we can easily solve for n. So we do so, and n is going to turn out to be the ratio of the logs of the pressure ratio to the volume ratio. Now you need to make sure that you track your indices carefully, because in one case it's P1 over P2, in the denominator it's V2 over V1. Put in the values, and sure enough we get that it's going to be a pretty clean number, n equals 1.5. So the index of this process is 1.5, meaning that now that we've solved that, we know as long as we're executing the same process, that p times v to the 1.5 power will always be the same constant for that process. Now for a different process, n can have different values, and clearly it doesn't need to be an integer, but for this particular process, n equals 1.5.